QC software is web-based, and that means we can log on to this from any device in the world that has internet access, and we can access our QC data remotely. So this is our home screen, and on the home screen we can see these 10 large orange tabs in the middle, and this lets us navigate to every different area of the software that we want to look at. So today we aren't going to go through every single tab because that would take a little bit too long, but we're just going to highlight some key things that your lab may be interested in looking at on a fairly regular basis. So the first thing we have is our charts, where we're going to look at our Levy-Jennings histogram and performance summary charts as well. So in this list we have all of our QC tests that we have registered. We can see that this is for Lab 1, which we've just titled Demo 1. So we can see all the tests registered for that lab. We can see the analyte name, the chemistry type, whether it's immunoassay, clinical chemistry, hematology, whatever else, the reagent method that we're using, the unit that we're reporting our results in, the instrument that this test is being run on, and finally the QC lots that we are using as well. So what we're going to do is we're going to search specifically for one of our analytes. So we will look for alpha-fetoprotein. So we will look for data from this first test from Lab 1 run on the Cobus A, and we'll look at the same test but from Lab 2 on the Cobus B instrument. So we'll press next, and then we will choose our parameters. So say for instance we want to look at all of our QC results from the last year, for example. We then choose which QC lots we want to display on our graphs. We only have 2 lots for this particular QC, so we will just turn on lots 1 and 2. We will then combine so that all of our results will be shown in a single Levy-Jennings graph, and we will finally press generate. And we can see that QC graph generated on here. So I'm going to zoom in just so we can see things a little bit more clearly. So if we scroll down a little bit, we can see that we have all of these different colored bars, and these colored bars represent a different test run on a different instrument. So we can see here we have 1573 EC, and we have 1621 EC. Those are our lot numbers on instrument A from Lab 1, and the same lot numbers from Lab 2 on the instrument B. So say for instance we want to just compare lot 1573, so we can just left click and turn off the other 2 lots so that we can see these a little bit more clearly. So in this case, the target that we are using to compare against is a cumulative target that is calculated based on the QC results that we upload. So it takes 20 results for us to upload before it will assign our QC target and ranges. So that's why these first 20 results here are just straight on the mean, because our software has been calculating, and then from this point onwards it has assigned a mean and we're being compared against that. So we can see on the left hand side on the y-axis we have our SDI. So this is fixed at a rate from +3 SDI to -3 SDI. So we can see from our performance here that performance looks pretty good. It's fairly up and down. Our performance is spread, it fluctuates randomly above and below the mean. Generally our results are within 1 SD, so nothing too crazy in terms of our performance there. But what this chart means is that we can very simply fulfill the ISO requirement for inter-laboratory comparison and inter-instrument comparison, because we can put as much data on this QC chart as we want, as much or as little data as we want. So what we will do next is we will uncombine the chart and look at our individual Levy-Jennings charts for each lot number of QC. So we can see if we scroll down here, this is for Lab 1, lot 1573 EC on the Roche Cobus A instrument. So we can see each one of our results. If we hover over one of these points, it will give us the date and time that this result was entered, as well as the result itself and finally the SDI, so how far we are away from target in terms of SD. And our software operates a very straightforward traffic light system. So we can see these points are all highlighted in green. So green means that they're fine, they have been accepted. We can then see some of our results are highlighted in orange down here. So those orange tests are alert. So an alerted test just means that it's something that we will want to keep an eye on. It's not necessarily a QC error, but it does mean that it's in that erroneous range. So it could be an error, or it could be nothing we need to worry about. So just something to keep an eye on. If we have any rejected results, those will be highlighted in red. A red result then just means we need to investigate straight away. That's definitely an error. So we can assign our own QC multi-rules, whichever ones we want to use, and those will be automatically applied on our Levy-Jennings charts. So we can set different multi-rules for different tests, and each test can be micromanaged to be as efficient as possible in terms of the multi-rules we use. Because for every test will have its own sigma performance. So that means every test might need slightly different QC multi-rules to optimize its efficiency. So if we left-click on one of our QC results, we can also enter comments. So say, for instance, this result was highlighted in orange as an alert. We might want to say why we think that was. This was an alert potentially because of a calibration issue. That was then fixed, and our results returned to normal. So we can just have full traceability on here. So once we enter a comment, let's just say new comment. Once we enter a comment and save, we can see that orange circle has now transformed into this little orange triangle. That triangle is just a really quick way for us to note that there has been a comment attached to that result. So again, it's a pretty straightforward idea. And on these graphs, we can see on the right-hand side, we have the right-hand y-axis, we can see the actual concentrations as well. So 13.073 is our target value from our own established running mean. And then we can see our positive ranges and negative ranges above and below. Okay, so that is our Levy-Jennings charts. These Levy-Jennings charts can be printed or can be saved as a PDF. So I know that some labs will print out their charts on a weekly basis, some will do it on a monthly basis. This can be done at any time on demand. So the next chart we're going to look at is our histogram chart. So we're just going to combine that and then generate. So our histogram shows us the dispersion or the spread of our results around the mean value. So we can see on here, if we just zoom in a little bit, we can see all of our different SDI ranges or SDI brackets. So we can see, for instance, if we look at how many of our results have fallen between -2 and -1.5 SDI, we can see that in here. So if we hover over that blue bar, the blue bar then corresponds to log 1573 EC on Roche Copus A from Lab 1. We can see that our frequency here is 3. So that means 3 of our results are falling within that SDI bracket. So what we want to see from this graph is just a normal Gaussian distribution with most of our results and our highest bars falling in and around the 0 mark. So let's look at each of these lots one by one and see if we can identify any performance issues. We'll turn everything off except for this orange test. So what we can see here is that our results are pretty even above and below the mean. Our results here are maybe slightly higher in terms of where the bars are, slightly higher on the negative side. So that might mean we have an ever so slight negative bias, but it doesn't look like it's anything to be too concerned about just yet. So obviously, if our bars were very high in this range here, that would be cause for concern, especially if that same thing wasn't reflected on the other side. So our histogram charts is where we can identify potentially more long-term bias, whereas our Levy-Jennings charts will be for evaluating day-by-day QC performance. So that's our orange test. Let's then look at our green test. Again, we can see here our performance is fairly normal, above and below the mean. we do have one result which is falling between the 2.5 to the 3 SDI range. So that's something you want to keep an eye on. But again, nothing too terrible happening there. Then if we look at the results from lab 1, again, it seems to be fairly normal distribution of results. So everything seems to be okay. And for our blue test, again, the same thing that we've seen here. Performance is fairly standard across the board. So it shows that for lab 1 and lab 2, everything seems to be going quite well. The next chart we will look at is our performance summary chart. So with our Leafy Jennings and our histogram charts, we're looking specifically at our own lab's data, whereas with the performance summary chart, we are looking at our lab's data compared to peer group data. So again, it answers that question, when do we use the peer group and in what context? This is one of the best ways to use that peer group data for comparison. So we can see our performance summary chart here. So our colors are just a little bit off due to this projector, but we can probably see in the middle we have this desirable box here. The desirable box is where we want our results to be falling. And so our chart is plotted in terms of SDI on the y-axis and CVI on the x-axis. So remember, in this case, SDI and CVI is just our lab's SD and CV compared to the peer group SD and CV. So all of our results at the minute are falling within that desirable box. So our performance is pretty good for all of our tests. However, if we had some of our performance, say, in this borderline box, we would know